Hello everyone, we are 이무현, 전소연, 장준혁, 조우현, and we visited Inwang Mountain. We conducted the stereographic projection at Inwang Mountain. The table of contents is as below.
Hello everyone. Today I will introduce Seterographic projection, a method to analyze long mass discontinuities. Our team's project will be conducted at Inwang Mountain. It projects a three-dimensional sphere onto a two-dimensional plane, simplifying complex geometry and enabling easy visualization of structural properties by deriving precise coordinates. This approach helps in analyzing geological structure actually. Let's explore further in the next slide. For data collection, we use Field Move Cleaner, a mobile app for structural geologists. It measures orientation like strike and deep dialect in the field, making it easy to record, visualize, and export data. This tool ensures accuracy and efficiency in our analysis. Actually, this page had the most to say. When we went on our field trip, two members of another team were on their way down. One of them said they couldn't climb all the way up because they were in full physical condition and could only make it halfway. But as civil engineers, we don't take no for an answer. We got them to the top. On a personal note, as a transfer student, I felt genuinely happy to hang out with friends not just on campus, but also outside of school. Deep down, I did feel a bit reluctant at first, thinking of it as a somewhat bothersome assignment. But after going through it, I realized it was such an enjoyable project.
I will now explain the theoretical background. There are two key concepts in structural geology. Strike is the compass direction of a plane's intersection with a horizontal surface, and dip is the angle and direction of plane's inclination perpendicular to the strike. These parameters are crucial for understanding and describing rock formation in the field. Here's additional concepts. Plunge is the angle a line descends from the horizontal, and the pitch is the angle between the strike and a line within the plane. These measurements help analyze linear features and their spatial orientation. Stereographic projection analyzes the geometric stability of structures. It projects a hemisphere onto a 2D plane, representing planes as gray circle and lines as points. This method is widely used to assess the stability of slopes and structure planes. From here, I will tell you the result. We can get delta and beta through the process. And with the delta and beta, we can get L, M, N. And through the calculation, we can get K, F. This table summarizes measurements for 8 rock samples, including strike, dip, plunge, and pitch. These values reveal structural patterns and variations critical for stability analysis. The StereoNet visualizes. Left one is pores stereographics, projection showing pore orientations. Right one is planes stereographics, projection showing plane orientations as grid circle. These projections highlight patterns and structural stability. This table highlights key orientation parameters like strike, dip, plunge, and pitch. For example, rock 1 is strike is 187 degree, dip is 78 degree and 153 southeast. Plunge is 75 degrees and pitch is 18 degrees. These analyses aids in understanding structural trends across the samples.
Now I will explain the analysis of joint orientation data, specifically focusing on the stripe, dip, and resultant directional components and discussion of the result. This table summarizes the numerical values of each variable, calculated using the direction cosine method. Using these three formulas, the L, M, and N values for each joint were computed and summed up as follows. After calculating the magnitude of the resultant vector R, the L, M, and N values corresponding to all can also be determined. The results are as follows. This stereonet represents the representative orientation derived from the analyzed data. The red-gray circle on the stereonet corresponds to the mean orientation of the planes, and the red point represents the resultant direction derived from the cumulative calculation of all the data points. The circled region highlights the group of joint orientation derived from the data. These joint sets represent consistent patterns in the rock structure. By projecting the set of joint onto a stereonet, we can estimate the failure type. It is a plane failure where the critical combination of joint orientation and slope inclination may lead to sliding failure. By correlating the stereonet data with failure mechanisms, we can assess the stability of the geological system and implement necessary intervention. In this process, manufacturers can affect the measurement accuracy of the results. First, device accuracy. The application may not be accurate and measurement results may have errors. Second, environmental conditions. For example, diverse weather conditions or sediments, crustal movement can affect measurements. Third, user error. The user's skill level and attentiveness during measurements are important. Fourth, complexity of terrain. If the surface of the rock or terrain is complex and irregular, accurate measurement of slope and directions can be challenging. Finally, lack of data. Insufficient experimentation can lead to statistical uncertainty. This brings me to the end of our presentation. Thank you for watching our video.